Hi everyone, happy Friday. I would like you to follow along with this video with your notes packet on the page saying day 12, interpreting line of fit, and it's going to continue on with what we were working on yesterday. So there's 3 problems on this first page. I want to go through one of them with you, and then I'm going to have you pause the video, try the other 2 problems, and then come back and check your solutions, or not solutions, you're not really solving, you're going to be doing a lot of interpreting, a lot of writing today. So the first one will be a nice demonstration on how it's going to work. And then the back page we'll go through together with the graph. All right, so first problem, it says, the following function represents home prices in Siesta Key, Florida in thousands of dollars and the distance of those homes from the beach in miles. And we have this equation that we're given that's going to be our model for the situation. So think about what everything represents. So first thing we are asked to do is define the independent and dependent variable. So our independent variable is the x, our dependent variable will be the y. And by define, remember, like we always do, we want to talk about our units. What is it representing? What is it measuring? So when we think about the 2 things we're talking about in our problem, we have thousands of dollars representing a cost or a price of the home, and we have the distance in miles. So would we say dollars per mile, or would we say miles per dollar? Which one seems to make a little more sense? Okay, hopefully you're thinking the dollars per mile. So our house, if you think about it at a beach, if your house is on the beach, it's going to be more expensive. The further away you move from the beach or from the waterfront, the less expensive your home would be. So that explains why our slope is negative. So we have a, well, before we get to the slope, hold on a second, let's define these variables. So our x and our y are independent and dependent variables. If we're saying dollars per mile, remember your slope is your change of y over change of x. So our change of y is our dollars, so that's going to be our cost of the home. Cost of home. And now don't forget, we're not measuring it in regular dollars, we're measuring in thousands of dollars. So we always want to put that unit on there so we know if it's thousands or millions or individual dollars. All right, the x coordinate, our change of x, the denominator was the mileage. It was mileage representing the distance. It was our distance from the beach. In miles. All right, perfect. So defining variables, check, that's done. Let's move over to the other side. Right next to it, it asks us to describe the correlation. So yesterday we talked about correlation versus causation and how correlation worked, how the 2 unknowns compared to each other. So if we think about our 2 unknowns, our 2 variables that we defined, as would you say what's happening to the distance from the beach compared to the price of your home? So we want to be able to write a statement or a sentence about it. So as the distance from the beach increases, we put an arrow, as the distance from the beach goes up, the cost of the home, what happens to that? Goes down. Okay? So this is what we would refer to as a negative correlation. As one variable is increasing, the other variable is decreasing. All right, over to the slope. Interpret the meaning of the slope. We were just talking about the slope over here in this upper right-hand corner. We talked about that our slope was being represented by dollars per mile. Okay. Our cost per our distance from the beach. Well, we know from the equation up above, the slope is negative 35. So think of it in terms of a ratio, negative 35 over 1. So how can we write a sentence or a statement about the slope being a value of negative 35 over 1? how about if we explain it as for every 1 mile, further from the beach, what happens to the price of the home? Where does that negative 35 come into play? For every 1 mile we go further from the beach, cost of home goes down by how much? $35? Not $35, but $35,000. Every 1 mile we back up from the beach, we drop our home price by $35,000. So that's going in with our negative correlation about saying the closer to the beach, the higher the price of the home, the further from the beach, the lower the price of the home. So it all ties together. All right, now it's asking us to interpret the meaning of our y-intercept. Right now, when we look at our equation, we have a y-intercept of 0, 315. Now remember, the 315 is your y-coordinate. And your y-coordinate, this is your miles, this is your dollars. So keep in mind what each unit represents. So at 0 miles from the beach, we have a home at $315,000. So that's exactly what our statement should be saying. That's what our y-intercept is telling us, that homes on the beach, because they're 0 miles away, cost $315, remember, $1,000. And of course, this would be an average. All right, so now I would like you to press pause for a moment, take a minute and look at number 2, see if you can make some connections to number 1, and then come back. Actually, try number 2 and number 3. Fill in everything you can, make connections, what we talked about yesterday, what we talked about up above in problem number 1. Give it a best try, and then come on back and check out what you have compared to what I'll have written out on the answer key. All right, see you soon. Welcome back. Okay, take a minute. Number 2 is on the screen now. Maybe hit pause, take a minute, look through and check out each of your answers and see if you agree or disagree, and be prepared for us to discuss these on Monday. And then do the same thing. After you check it, then hit play again. I'll scroll down to number 3, hit pause again, check number 3, and then come back and we will start working on our graph on the back. All right, so here's number 2. And then let me scroll it down. I'm sorry, here was number 2. Here's number 2. Go ahead and check it. Hit pause if you need. And then here's number 3. Same thing. Hit pause so that you could go through and check. And then come back and we'll be on the graph on the back. All right, here is the graph on the back. Last thing we're going to do today, we have a word problem with some data given to us about a pizza place. Table below highlights the cost of a pizza, so that's one of our things we know, in various sizes from 3 different pizza chains. Domino's, Pizza Hut, and Papa John's. So they're all put into this table based on the size they offer and the price they have. So it's not separated by pizza chain, it's just a size versus a cost. So that's why some of the sizes are duplicated, because the different chains may all have that, say, 12-inch size. All right, so let's identify our dependent, independent variables. Remember, independent would be the x, dependent the y. So would we say the cost per size? Or would we say the size per cost? Think about which one makes more sense to you. And hopefully you're choosing cost per size. So cost per size would tell us that it's the change of y over change of x. So our y is our cost in dollars. and our x would be the size, the unit being inches. So first thing we need to do, label our axes and make a scatter plot. So we're going to go ahead and plot the points. So go ahead, hit pause, go through and plot all of your points. We have our size on the x-axis, we have our cost on the y-axis, and put those points all over our graph and then hit play again when you're done. Okay, so the plot is done. We have all our pizzas. They're all kind of glommed together there, but we could definitely see a correlation. So think about how you would describe that correlation. We're seeing that nice uphill trend, so think about what an uphill slope would be. It would definitely be a positive correlation. And to describe that correlation, how would you describe it in a sentence? What's changing and how by what's changing and how. So think for a minute how you would compare your two units, your x and your y. How about as the size of the pizza goes up, what's happening to the cost of the pizza? There you go, the cost of the pizza. Would you say up or would you say down? You got it, it goes up. All right, so that's how we describe our correlation. How does one variable change? How does the other variable change? So it then says, using the coordinates 10, 799, and 14, 1295, write an equation of a line of fit. So basically, if we're given 2 points, think what we've been doing in the past to make an equation. We're going to find a slope, and then once we find a slope, we're going to go into point-slope form. And how about we use this first point, and then you're going to take your point-slope form and change it into slope-intercept form. So it has a little more meaning to us. So hit pause, go ahead, find your slope, write a point-slope form equation, and then a slope-intercept form equation. All right, check your equation. For the slope, I had 1.24, which is telling me it's a $1.24 increase in price as the pizza gets bigger by the inch. I wrote a point-slope equation, transformed it into a slope-intercept form equation, so take a look at those, hit pause if need be, and then we need to come back and answer some questions about our slope and y-intercept, which is why I took it all the way through to that slope-intercept form. All right, the y-intercept. The y-intercept is 0, negative 4.41. So that $4.41, because this is money, this is a dollar amount, how could we explain that? It says a cost of a pizza with a diameter of 0 inches is negative $4.41. So cost of 0-inch pizza is negative $4.41. So similar to one of the other problems, this y-intercept, which happens sometimes in word problems, really has no value, no meaning to us in the real world. All right, what about our slope? I mentioned it a minute ago. For every inch the pizza increases, what happens to the price? For every inch the pizza increases in size, the price, did it go up or did it go down? Positive 124. The price increases, because it's positive, by $1.24. That's a dollar sign. There you go. $1.24. All right, so down here, my video is about out of time. So go ahead, plug in your 20 pizzas, find your cost, and then plug in your dollar amount, find your number of pizzas. You should be able to get $20.39. And when you work out this one, it should come out to be a 13-inch pizza. But I do